Good morning. I am Dr. Mahajabin Fatima from Electronics and Communication Department. I am taking lab experiment of control system via Matlab. Subject code is EC404. Today I am taking experiment number 3, linear time invariant system representation through transfer function. So let us start. Experiment number 3, linear time invariant system. Aim of this experiment is to represent linear time invariant system through the transfer function. Objective of this experiment is to learn how to write and solve transfer function of a control system in Matlab. Come to the theory. The linear time invariant system are the two system properties that greatly simplifies the study of systems. A linear system also obeys the principle of superposition. This means that if two inputs are added together and passed through a linear system, the output will be the sum of the individual inputs. The time invariant system has the property that a certain input will always give the same output up to timing without regard to when the input was applied to the system. A transfer function or the network function is a mathematical representation. It is the relation between the input and the output of the system. The transfer function is the ratio of the output to the input, assuming zero initial conditions. So you can see here, the systems can be single input or single output CISO or multiple input multiple output MIMO. So the linear time invariant system, that is LTI system, can be represented through the transfer function. Now in this experiment we will see how we can write the transfer function in Matlab. Now take one example, r equal to s plus 5 upon s square plus s plus 10. So this LTI system can be represented as a ratio of polynomial functions. Now the example of creating LTI system transfer function. The LTI can be represented through the transfer function or through the zero pole gain and CISO system. Now example of creating transfer function. The transfer function can be made by numerator and denominator coefficients. TF is the command to write transfer function in polynomial form. Now take one example. NUM numerator is equal to 1 space 5 and denominator polynomial coefficients, let it be equal to 1 to 1. So these NUM numerator and DEN denominator specifies the polynomial coefficients of numerator and denominator. So I am writing here, I am copying this command. I am writing this command here on Matlab and solving here. So you can see for the numerator polynomial coefficient NUM is written, and for the denominator DEN is written for the denominator polynomial coefficients. Now this is evaluated. See this command, system equal to TF numerator comma denominator. This TF is the command. See here, this TF is the command to write the transfer function in Matlab. So I am copying here this command and doing evaluating here. So see here, sys equal to TF numerator comma denominator. Sys is used for the system. You can use x, y, z, any variable instead of this s, y, s. TF is the command used to calculate the transfer function in Matlab, and within the parenthesis the numerator polynomial and denominator polynomial coefficients are written, are used. Now see, this is evaluating. Now you can see here in this, with the help of TF command, the transfer function is written, and it is equal to how much? S plus 5 upon S square plus 2S plus 1. So you can see in this the numerator polynomial is S plus 5. Numerator polynomial is S plus 5. In this, the coefficient of S is 1 and coefficient of S raised to 0 is 5. So it was written here at numerator, it was written here numerator equal to 1 space 5. Accordingly, the denominator coefficients are written. The coefficient of S square is 1, the coefficient of 2S is 2, coefficient of S raised to 0 is 1. So I wrote here all these values. Now come to next command. Let this be, let I am taking this n equal to 1 and 0. I am copying here, writing the value here, pasting here this n equal to 1 0. So you can see here the value is 1 and 0. Now write the coefficient of denominator. D is equal to, let's see what we are using, 1 1 5. So I am writing here 1 space 1 space 5, close by square bracket. So now here the coefficient of polynomial of denominator is written here. Now I can write the transfer function with the help of these polynomial coefficients. Let it be x equal to transfer function TF, write within parenthesis n comma d, n for the numerator polynomial coefficient and d for the denominator polynomial coefficient. Now you can see here this executed the transfer function. Now the result is transfer function whose numerator polynomial and denominator polynomial were given. Now see the next method to write the transfer function. See here, this the another way of writing transfer function with the help of variable s. For this, specify polynomials using s as the polynomial variable. See here, s equal to tf within parenthesis within apostrophe s is written, and with the help of this we can write the transfer function. So see here this example. In this example you can see here s equal to tf within parenthesis within apostrophe s is written, and then system is written in terms of s. So with the help of this the transfer function can be written directly. See here, I am writing here. So I am deleting this example term from here. I wrote s equal to tf within parenthesis within apostrophe s is written, and then any variable you can write here. I can write let it be x equal to s plus 5 divided by s square plus 2s plus 1. So now you can see here I am executing this term. Now you can see the transfer function is written directly. So instead of writing the polynomial coefficients of numerator and denominator separately, we can write the transfer function directly by using tf as command. So this much about the today's experiment. Thank you, students.